Okay, in this video, we are going to discuss about version control. First, let us see what is version control and how it is important in software development. This is not just all about these, this is not directly only involving with the server-side web development. This version control is mainly a main part, essential part of almost all software development, right? What is version? You know, in our softwares, we have versions. In Windows, we have different versions. In Microsoft Office, we have different versions. Versions mean, let's say you have a base software, then you are adding some additional features, new features to the items, to the software, then it will become the latest version. After that, if you remove something, unwanted part from your software, then it becomes the another version. Likewise, we have versions. In some cases, especially software development phase, we have to divide the software development process into versions, right? Let's say you are going to build a software or web application, then part of your group will be involving with the backend development. Another part will be involving with front-end development. The other part will be developed to database system, right? Three people are involving with three different scenarios, right? Addition to that, inside the single scenario, let's say front-end development, we can divide it different groups, different parts. Home page design, contact us page design, sign up page design. Likewise, we can divide the software development process or the software further, right? The idea is that more than one people are involving with development of same software. Then we are adding some features time to time. Then it will become a version wise version. The version will be updated, right? Then there should be a process to track these changes. There should be a process to track these changes. In some cases, you have to see, you have to check who has made the change, what and when, why these changes happen to the software. Likewise, you have to keep a track of history, right? Because more than one people are involving with the same software project, then you should have to have a track of history with who has made the change, why, when, and what the particular person uh, has made some changes to the software, right? This is the importance. That's the idea of version control, right? You are keeping a history about the software version of your software. That is the idea of version control. Then there are three main version control systems. First one, local version control system. Second one, centralized version control system. Third one, distributed version control system. Let's take one by one and see what is the key idea of three different version control systems. Local version control systems, it is all about the storing your project in local directory. Directory means inside some different folders, you can store your project. Like I will show you an example. You can create a folder to store your project. Inside that, you can create, uh, some folders for version 1, another folder for version 2, another folder for version 3. Likewise, version wise version, you can create folders, directories. Then inside that, you can store the required files. Let's say you are going to create some text files. File 1, then file 2, and so on. You can keep your files related to the version 1 inside the version v1 directory. Same to that, you can create or you can store the second version of your software or the related files inside the version 2 file folder. Likewise, version 3, you can store it, right? This is all about the local version control system. What's the key idea? You can create a main folder or a directory for the project. Inside that, you can create different folders to maintain the versions of your software, right? This is the idea of local version control system. What are the disadvantages? This is good for small scale, very small scale projects. Especially only one person is involving with the software development process. This is good, right? But let's say you are going involving with the collaborative project. It means more than one people are involving in the same project. Then what will happen? It is at the end you have to merge different parts of the project. Let's take the previous example. One group is involving with front end, another group back end, another group database, right? At the end, there should be a manual method to merge these three different parts into a same project as a single unit, as a single project. Then you have to pay a more attention or more workload to handle or to merge these three different parts of the project as a single unit manual. Then we can become, to overcome these issues, we can become another solution, centralized version control system. To overcome the issues of this local version control system, we can come up with another solution, centralized version control system. The key idea of a centralized version control system is, again, more than one developers are involving with the same project. More than one developers are involving with the same project. Let's say developer 1, developer 2, developer 3, developer 4, right? All developers are connected with a centralized device. Let's say a server, right? Then the copy of the project is stored inside the server. Stored inside the server. Then through the server, not directly, through this server, these developers can share their software part or the part of the software through other developers. Let's say D1, the part of the D1 can share with others through the server or the centralized device. D2, he can share their part with the D1, D4, and D3. Likewise, through this server, the developers can share the copy of the project with each other. But there is a problem. What will happen when this server goes to offline state? Offline state. What will happen? All these connection will be break. All this connection will be disconnected. Then the developers should have to wait until again this server is again come into the online state, right? This we call this one as point of failure. Point of failure. Point of failure means all of these nodes, all of these developers are highly depending on this centralized device. Once this centralized device or the point is break or going to offline, entire network will be vanished or entire connection will be disconnected, right? This is the key disadvantage of using centralized version control system, right? Then to overcome this issue, we have distributed version control system, right? Git is an example of distributed version control system. Distributed version control system means, again, more than one developer are involving with the same project, but this is the developer 1, developer 2, developer 3, developer 4, and developer 5. Let's assume 5 developers are involving in this project. Then the important thing is, uh, each and every developer has its own history of their project. In previous case, all the history, all the versions are stored inside the server, only the server. But in this time, each and every developer has its own part of the history, part of the software history, right? Once the centralized system or the server is going to the offline state, this developer can share their project versions with the others, because already these versions are stored inside the local machine, as well as these items are stored inside the servers as well. But in this case, more than one servers are involving with this process. More than one servers are involving with this project. These servers are connected to each other. If uh, one service goes down, another two remaining servers can handle the process until this offline server is recovered, right? This is the key idea of distributed version control system, right? What are the importance? What are the advantage of using distributed version control system? First one, more than one developer can involving with the same project. And the second one, this is not highly depending on the single point, single server. This is uh, this is integrated with more than one server, right? Like Git, they have more than one server. If the one server is goes down, other two servers can keep the process without any doubt until the uh, crash server is recovered. And the other important thing is uh, the history. History is already stored inside the local directory in each and every developer site. If the all of these servers are goes down, it is not a big issue. The developers can share their project with the others, because already all the versions are stored inside the local directory, local device. Right? This is the key idea of distributed version control system. Right. I hope you have got a good understanding about these three different version control systems: local version control system, centralized version control system, and distributed version control system, and their pros and cons. Right. Uh, then what is Git? Git is a is an example of distributed version control system. Git, right? Before use Git, you have to install Git to your machine, your device. Locally, you have to store them using the Git official website. You can download Git to your machine, not GitHub, Git download. Using this website, you can download Git, the latest version of the Git. Then you can simply install it. Then let's say this is your project. This is your project. Then you have to, I will remove this folders. Then first you have to configure Git to your project. Now the project is not configured with the Git. Then first you have to configure Git with your project. There are two ways to do this one. Once you install Git successful to a system, there are two methods you can use. You can use Git graphical user interface, right? You can create directories, whatever the things, using this graphical user interface, or else you can use Git bash command line interface. I'm recommending you to use this command line interface. This is good for developers, right? First, you have to initialize an entry repository to your project. How you can do it? Git init. This is the command you can use to initialize a Git to your project. Once you enter, it says Git is initialized with this project. But if you see, you cannot see anything inside this folder, right? But once you show the hidden items, you can see there's a folder is created. All the configurations are added to this, right? Uh, it is not good to touch these items. If you remove or change this one of these items, your project will be going to the crash state or whatever the things, right? It is good to hide this git initialize folder from your project, right? Then you have to configure GitHub with your project. Configuring GitHub. First, you have to create an account in GitHub, github.com. Inside this, you can create your uh, account here. This is open source platform. Then you can create your account here. Then at that time, you have to give a profile name as well as an email, a password to access this account, right? Then when you are going to configure, there are some commands. First, you have to configure the username here. The username of the GitHub. In my case, this is my username. This is my username. Then I have to configure this. I have to configure this with the local project. How you can do it? Let me see. Git config dash global. Sorry. Git config dash global. If you remove global, this configuration is only valid for this project. If you add global here, this will be valid for all of the projects you are doing with your computer, right? Therefore, I'm keeping the global word here, global space user dot name space within quotes. I can pass the username here. I can just copy this and paste inside here. All right. Then we have to configure the email as well. Git config dash global user dot email. Again, double quotes. I can give my email I'm using to create this GitHub account. Okay, it is successfully configured. The next one is you can configure an ID as well. The VS Code is much better for this purpose, right? We can use VS Code inside this project with this extension, or you can simply use VS Code with your project. Then First, you have to add an extension here. Go to your extensions. Then you can search git lengths. You can add this extension to your system, to your VS Code. Then you can use git commands here, as well as it gives a good interface to track the changes of the files. Right. Right. Then we have already configured our project with the Git. All the details are stored inside this folder. I have shown here before. All the details are added inside this configuration folder. Okay, now you have already configured your project with Git, right? Okay. Then what else? Okay, let's try to understand what is the pipeline of Git. Okay, first pipeline or the workflow of Git. Let's use some Unix command here. Using ls command, you can check the file folder content. If you added ls command, it is not showing here anything. But if you say ls-a, it shows this configured file. This configured file is showed here. See, .git file is shown here if you use ls-a command. Right. Then let's try to understand the Git workflow or the pipeline of the Git. Right. Okay. Now I'm going to create an empty file, a text file. Let's say file 1.txt. Then I'm going to add some text here. This is the very first file created for the project and save. Right. This is the very first file created for the project. This is my this is the first file inside the project. Then if you check the status of this project using Git, what it says, Git status, it says untracked files. We have only one untracked file. It means now you are not adding this file to the history, record of the history of the Git. How you can do it? You can use add command. Git add, you can say file 1.txt. Now it is added. Then let's see again the status of the project. Then it says no commits yet, but your branch is cleared. But there is a file to commit. If you add your file to the if you add your file using add command, this file goes to the staging area. We call it as staging area. It means temporarily stored inside the history. Then you have to commit it, permanently stored inside the local database of the Git. How you can do it? You can commit. The command is commit -m. Then you can give a proper message here, right? You can give a proper message here to identify what are the changes we did to the file, right? At the very first time, I can say this is the initial commit. Now the file is committed and permanently stored inside the local storage of the Git, right? Or In other words, we can say we are starting to track the changes of the files. Then if I check the status, git status again, now you can see on branch master, we are in the main branch, nothing to commit, working tree is clean, right? Then if you go back to the editor, you can see the green color U letter is disappeared. Then if I make some changes again to the file, this is the second version, and save the file. Again, there is a letter here, letter M here. M means modified, right? You are modified the file, but no any changes. See, there's a text here also shown here as well. See, who has made the change, how long it takes, and uncommitted changes. It shows all of these things inside this editor because we are adding an extension here, right? Okay, the author shows the when you make the changes there, who has made these changes there, right? And also there is a reminder here. There are some modification in the file, but we are not still committed to the it local storage. Then again, if I see the status here, git status, you can see there's a modified file. Then I can add it to the staging area, file1.txt. Then you can commit it commit -n, then you can give a proper message here. Second line edit, right? If I go back to this, you can see the warning is disappeared. Then if I create one more file here, file2.txt, this is second file. Now you can see there's a letter here, untracked. Untracked means we are still not adding this file to the staging area, right? Still we are not adding this file to the staging area, right? Now the first file, we are not making any change, but only for the second file, we are making some changes. Then if I check this status, you can see file 2 is not tracked. And you can use this command, git add the file name or dot. Dot means all files. It represents the all files, right? Then git commit -n second file. Now I have 3 commits, right? Then the letter is disappeared, right? Okay, let's try to understand what happened here using a diagram, right? Give me a second. Right, what happened? In our project, we have two files. File 1, file 2. Once you create a file, it is not still in the staging area. It is still not starting to track, right? It is not started to track. Then you can use git add command. git add command. Once you run this add command, this file is goes to the staging area. Staging area. The first version will be stored. File 1, first version of the file 2 is stored. Once you use the git commit command, it will permanently stored inside the local storage of the git. Right? File 1, file 2. This is the first version. This is the first version of the file, and this is the first version of the file, file 2. Then let's assume if you are making some changes to the file 2. If you are making some changes to the file 2, then it will become the second version of the file. But if you still this file 2, the second version of the file is not added to the staging area because we are still not run this git add command. Once you run this git add command with the file name, instead of using dot command, file 2, this second file from the staging area will be changed. Second version of the file 2 is only changed, but the first version of the file is still remaining in the staging area. Once you add git commit, the version of the second file will be changed, right? Then let's assume you are creating another file, file 3, then it is in its version 1. Once you run the git add file 3 here, then first version of the file 3 will be added. Then once you commit this, file 3 is stored inside the local storage as the version 1, right? This is the idea of staging area. Then once, let's assume you are going to delete this file 2. You realize that you no longer needed this file 2. What will happen? Once you delete this file, still this file is alive in the staging area, but we are not added to these changes to the staging area. Once you add git add file 2.txt, now from this point onwards, this file 2 is not available inside the staging area, right? Still, the file 2 is stored inside the local storage. Then if you git commit, this file 2 is removed from the latest commit, only for the latest commit. Let's assume you have commit 3 commits. As the very first commit, we added file 1 and file 2. As the second commit, we are making some changes to the file 2 only. Make some changes to the file 2 only. Right? As the third commit, we are adding file 3 to the commit, to the storage. Right? As a result, after this commit, how many files are available inside this first commit? File 1 and file 2. After the second commit, file 1 and file 2 is available inside the storage. As the third commit, we have file 1, file 2, file 3. Now, I'm going to delete this file as the fourth commit. Delete from the local storage, from our directory, project directory, then add to the staging area. Now, it is removed from the staging area. Once you commit this, it will create a commit here. Fourth commit, we are removing file 2. Now, what are the files available inside this storage? File 1 and file 3. But the important thing is, still all of these commits are stored inside the Git uh, environment as a history, right? All of these commits will be stored. Let's say after a few steps, so after few commits, you realize that you need F2 file again to the project. Then you can go back to the commit to direct, right? You can go back to the commit directly and you can recover this file too from here, right? This is the very, very important part from the Git version control system, right? You can go back to the previous stage, you can go back to the previous step and recover some deleted file, or else you can recover some previous version. The file is stored there, still available, not deleted, but you have made so many changes. But after few changes, you realize that you need the previous code. Then you can go back to the previous stage and you can recover the file from the Git history, Git repository. We call this as repository. These are the repositories. Repositories. We call it as repositories, right? This is the idea of uh, Git add and Git commit. I hope you have got a better understanding about this Git workflow or the Git uh, pipeline, right? Okay, the next thing is there are so many commands are there to do lot of things. I will share all of these commands with a small description through the LMS. You can access to the files, access to that file as well. Then you can try by yourself. The next one is now this history is only stored inside your local device. Now only this history is stored inside your local device, right? Now, if you want to share your code with the other collaborators for the project, you have to add this history to the remote repository. Remote repository. From this website, from this platform, you can create a repository for your projects. So let's try to create a new repository. I can go to repositories, then click on new, then you can give a template from here, or else you can uh, keep it no template as no template. Then you can give a repository name. CSC. I'm going to give a name here. You have to give a proper name here, right? CSC3103 S20, right? Then you can give a description. You can give a README file as well. README files represent or reflects the small description about your project. This reflect a description about your project. For this time, I'm not going to create a README file here. Then you can create a repository. Yeah, owner. You have to specifically say the owner. Then you can create a repository. Now, an empty repository is created. All the commands are here. You can use these commands. Git init, git add readme file, then git command, then git branching. Then the next important thing is now we have our local repository. This is our remote repository. Then there should be a connection between. There should be a connection between this repository, local repository, and remote repository. Then you can add your repository using this command. You can copy this link from here, or you can uh, where is it? You can use this command to add this remote repository to your local repository, right? Now the local remote repository is linked to your remote repository. then you can push these changes. You can push these all the commits to the remote repository using this command git push -u origin main. You are pushing all the changes to the main branch of this remote repository, right? At that time, you need internet connection as well. Fail to push some git push -u origin git push. Okay. Now the changes are committed and pushed to the remote repository. Once you refresh this, you can see the created two files are added and the latest commit message is appear here, right? Now, if I make some changes, let's say if I make some changes, first I will show you the complete diagram here. Now, you are sending the local storage to the repository, remote repository, right? Now, through this remote repository, you can share your code with your other collaborative developers, right? Then they also can share their code to the remote repository and you can pull them to your project. I'll show you that as well, right? I will make some changes to the file too again. Make some changes to the second file after uh, push to the remote report. I will make save this file and using git bash, I can add these changes to the staging area. Then I can commit this, commit dash m. I can give a proper name here, make changes to file 2, right? Now the changes are committed, but still the remote repository is still in the previous stage, previous version. See, inside the file 2, the only first line is there. Then you can say git push. Now these changes are added to the second file of this remote repository. And you can see this is the latest commit for the file 2. Only file 2 is changed. File 1 is not changed yet because I am not making any changes here. I'm not making any changes here, only I have made some change to the file 2 only, right? This is the idea of GitHub. Then let's assume another collaborate partner of the project is making some changes to the file 2, right? Please make some changes locally and uh, commit to the remote repository. Let's say made by the second developer, right? Then I'm saving this content. Saving means commit, right? You can give a description here, or else you can keep it as it is. Then you can commit this change to the project. right? Now the change is committed, but still this new change is not added to your local repository. This change is made by a different developer. This change is not still added to your repository. See, local repository, you cannot see it. See, then what you have to do is first you have to pull these changes to your local repository. Git pull. Now, once you open this change, you can see there's a change. And this is the author of the change, how long it takes, then what is the change, what is the commit, what is the message here. All the details are there, right? Then you can track all of these things using this Git version control system. Who has made the change? Why why this change are there? What is the changes? When is the change? When was the change this to the file? All the things are there. You can track this history using Git version control system. All right. Okay. Then the next important thing is viewing the history. You can say Git log. You can see all of these commits are there. This is the very first commit. Uh, this is the very first commit. This is the second commit, third commit, fourth, fifth. There are 5 commits. Commits are there, right? Then you can go back to these commits as well. You can say git. Let's say now you are in 5th commit, but you realize that you need the second version of your project. Then you can say git revert commit ID and press enter. All right. You can see there is a message here. This is the revert commit. This is the revert commit, and now this file is in its second version, right? Now this file is in second version. All the commits are disappeared. All the latest commits are cancelled out, and now this file is still this file is now in the previous or the second commit, right? If I open this, see, now this project is in its the previous version, right? The file one is changed, and these are the comparison. This is the comparison between latest version now the latest version and the previous version, right? Then this is the idea of reverting a commit, right? Let's say if you want to revert this project to the initial commit, you can take the initial commit from here. Then you can say git revert paste and press enter. And at that time you have to close these files. Now the file one is disappeared, right? Okay, this is the key idea of Git, right? You almost all the history is tracked. The author is there, the time is there, commit is there, almost all the things are there. Then you can directly go back to the previous stage. You can cancel out some previous changes. You can go back to the previous stage and previous version, and you can continue your work. There are so many things out there. Then you can make some branches as well in your directory. What is called the remote repository. You can see only one branch is there. You can create more than one branch inside the remote repository as well as this local repository. You can create some branches. Let's say you can create three separate branches for the previous example. You can create one branch for front end. You can create another branch for back end. You can create another branch for the database part. I will show you with the diagram. For the previous example, you can create a main branch. This is the main branch and this is the initialized part. Then you can, from this point, you can create three different branches. This for front end, this is for back end, this is for database, right? Then this respective developers can continue their work for the front end, for the back end and the database. In some cases, you have to merge front end and back end. Then you can merge this front end and back end and create a new single branch for the front end plus back end. And at the end of this project, you can merge database part as well with the front end and back end. Then you can come up with the single project, right? These are the branches, branch 1, branch 2 and branch 3. In this scenario, we are merging branch 1 with branch 2. And at the finally, we are merging, we call this, let's say this is B4. Then as the final stage, we can merge branch 3 with branch 4. Then we can come up with the single software project. This is the idea of version control system, and as the example Git, we can take an example of a distributed version control system. Then I will show you, share with you all of these commands, how to create branches, how to navigate through the branches, how to merge branches, how to make some branches in the remote repository. I will share a document with you through the LMS, and you can go through it as well. Right? This is very, very important, not only for web development. This platform or the version control system concept is very, very important for entire, almost all software development projects, right? Okay, then I will stop this recording, or I will stop this video from this point. We will meet by a new video with new topic.